Welcome to the next lecture of module data dimension, and we were studying about how we can select the most important features to predict a parameter. So for that, the next technique that we'll be talking about is select KBest. So this technique will help us to choose the best parameters by assigning it the chi-score value. Okay, so we have to find out the chi-score, and then this matrix will be used by the select KBest method, and we'll be finding the best parameters that can predict our outcome well. So for that, what I have done is I have already imported the libraries. So these are the basic libraries, NumPy, Pandas, and the important ones are select KBest method library and chi-square method. So we are importing it from the module feature selection in scikit-learn. Okay, so let's load it. And then we have the same data that we have followed in the previous lecture, so that you can tune up the results and see how the techniques are working on the similar data itself. Then we have the data head, data info, and the data description. As we have cleaned in the previous lectures, because before 6 AM and after 6 PM, we have zero solar radiation, so we can remove this data as to refine it. Okay, so that's the data we are removing. So clean 1 is this data, clean 2 is this data, and now removing both clean 1 and clean 2. So the final data we are left with is this, and then we have to prepare the input and output values that we have done in XY. Now when we are finding the chi-square, when we are applying this test over our data set, then the very important thing that we need to follow is that all these parameters should have a similar range, so that they won't create any bias in our data, right? So why I'm saying about bias is because the very working of this model depends on the formula, where we have to subtract the observed value from the expected value, and then the whole square is divided by the expected value. So the thing is that what we are targeting is basically, when we are talking about finding the most important feature, then in feature selection we aim to select the features which are highly dependent on the output. So when two features are independent, the observed count is close to the expected count, and which will make the chi-square value smaller, right? Because what we are doing is we are subtracting the observed value from the expected value. So if the features are independent of the outcome, then the observed value will be close to the expected value, right? Because there won't be any variation. And when we subtract both values, it will give us a smaller chi-square value. So if we have a high chi-square value, it indicates that the hypothesis of independent is incorrect. And what it means is that feature is more dependent on the outcome, and it can be selected for the model training. So the higher the chi-square value, the more the dependence of feature and the outcome is present. So we have to find out those features on which the parameter is highly dependent on, because in that case only we can easily predict our outcome, right? So this is what we do in chi-square test. We have scaled our data. These are the columns that we'll be talking about, and now we have to use that chi-square technique. We have to code it. For that, you have seen that we have already imported the data, right? And now we'll use this select KBest method. So we'll say best feature equals to, the method will choose select KBest method, and then we have to pass on the data, and then we have to use the matrix or the technique that we'll want. So we want how we want to function the score. So we'll say score function equals to chi-square. That is, we want chi-square test to apply on the data, and then we want the best 10 features from our data. Okay, so this is how data works, and now we'll fit this model on our input and output data. So best feature, then we have to mention the input and output data. So let's stream. We have to fit this model on our data, right? So here it is. The model is working perfectly fine, and then we'll find the scores of the resulting scores of the parameter correlation or the dependency chi-square value. So we'll prepare a data frame so that we can easily see what happened. So I'll say PD data frame. I'll prepare a data frame for the scores we have. So the model is named as fit. We have fitted all these values in it, and then we'll find out the scores, right? And then same is the case with, we have to prepare the columns for the values of the scores. So we'll say column equal to PD dot data frame, data frame, and then we'll pass on the value col. So we want our values corresponding to these columns. Okay, it's, yeah. And then we have to do is, we have to combine this data frame. So for that we'll say, let name it as feature score. So feature score equals to PD dot concat, and what we have to concat is, we have to concat the scores and the column in a column fashion, right? So we'll say what we have to combine, we have to combine the columns and the corresponding scores, and all this have to be done in a column wise fashion. So x is equals to 1, and then what we'll do is, we'll say feature score dot columns, and then we have to mention the feature names, so the column names. So first will be the feature, and then the other column will be score. Okay, here we go. And then we'll print our data. So we'll say feature score dot n largest. So n largest we have to pass on 10, and what values we want? We want the 10 largest value of score column, right? So that's the data we have. So these are the values this particular data is giving. It's giving a high value for the year column, then relative humidity, then temperature, then hour, then month. And this is showing that year is highly dependent with the outcome, then relative humidity, and then temperature. But when we find out the heat map, in that case temperature was highly correlated with our parameter, right? So this is why what we have to do is, we have to keep on using different techniques so that we can be ensure that the parameters we are choosing to train our machine learning models or to predict a particular outcome should be perfectly well fitted. Okay, so as to visualize it, okay, and then simply use PL plot, and what kind of graph we want, as you know, the bar graph, simple and easy. So here we go. We have plotted these values as it is given over here. So this is 504, this is 309, and so on. So this is how we find best features or the most dependent features using select KBest method, and in that we are using a chi-square technique which I have explained. So this was all for this lecture. Best of luck and keep following.